Hello everyone, welcome to the most awaited series on Apache Spark. This course is targeting a persons who are a beginner or professional who wanted to learn a data engineering and big data technologies. This series will help you a lot. In this series, we will not just learn about Spark theory, but also we will learn real world scenarios, use case scenarios, hands-on coding, and interview-oriented concepts as well. Right? So before understanding what is Spark, let's understand why Spark was created, right? So why do we need Apache Spark? In traditional big data world, so we had a Hadoop MapReduce as a compute engine, right? So what this compute engine will do is it will perform the tasks. So whatever the user wanted to perform there on top of their data, so those actions this MapReduce will perform, right? So MapReduce is powerful, but it had some major limitations. So those limitations are the MapReduce is slow and it was disk-based operations. So whatever the steps you wanted to perform, so it needs a disk support, right? So what is this disk-based operation? So it means each step in MapReduce, it reads data from a disk and write back to the disk, which makes processing very slow. Let's, for example, consider this use case. So on top of your data, so you wanted to select few columns. After selecting few columns, you need to apply few filter operations. So the filter means where class here. So after applying a filter, you wanted to do aggregate operation. Let's, for example, sum. So how it will perform is in select operation, first it will read the data from the disk. So once it read data from the disk, it will select few columns. So once it is selected, the data will be returned to the some disk location. Let's, for example, some HDFS location. So we have one more step, filter. So what this filter will do is, so whatever the data written by a previous operation, select, it will read this data from a disk. Again, it will apply a few filter operations. Again, this filter write data to the some more disk location 2, HDFS location 2. So we have one more step called aggregate. So this aggregate reads data from HDFS location 2. It is called a disk location. And it do some the aggregate operation called sum operation. And it will write back to the one more disk location. Right? So in this entire operation, the MapReduce required disk reads and disk write for each step. Let's, for example, we wanted to perform 3 operations. So MapReduce required 3 disk reads and 3 disk writes. So that's why it is very slow. And also writing MapReduce code is complex. So even if you wanted to do simple operations, we need to write a lot of code. So this is where Apache Spark comes into picture, right? So what is Apache Spark? So I hope you are understanding. So why we are moving to Apache Spark instead of MapReduce? Because it is a disk-based operation. So for each operation, it reads data from the disk and it will write to the disk. So that's why it is very slow, and also writing MapReduce code is complex. So what is specialty in Spark? Right? Spark is a general purpose, in-memory, plug-and-play compute engine. Let me write here. General purpose, in-memory, plug-and-play compute engine. So the term I mentioned here, in-memory. So it means So all these steps will happen inside the memory itself. It don't write any data to the disk. Right? So I will talk all these three keywords in this session. So and the Spark is capable of doing many things. So it can be used in a batch processing or a streaming processing, or if you wanted to query the data like in a SQL fashion, that also you can do. And also it can be used in a machine learning as well, right? So these are the things we can do by using a Apache Spark. So the batch processing means at a regular intervals. So if you wanted to perform some tasks on your data, so we can do that way as well. And also streaming data. So streaming data means real-time data. So without like so with a very minimal delay. So we can process that as well. SQL queries means so by using a SQL query fashion, we can query the data by using Apache Spark. And also machine learning. So we can use in many places like this. So where Apache Spark is used? The next question. Where Apache Spark is used? So Apache Spark is widely used in ETL pipelines to develop ETL pipelines, data warehousing, real-time streaming applications, machine learning workflows, and log processing. So there are many use cases. Okay. So all these places we will use the Apache Spark. And companies like Netflix, Uber, Airbnb, Amazon, and Facebook use this Apache Spark heavily in their data platforms. Right? So I mentioned ETL pipelines. So what is this ETL? What is ETL? So ETL stands for extract, transform, unload. E-transfer stands for extract. T stands for transform. L transfer load. What is extraction phase? So extraction phase, the extraction means pulling data from particular location. So that location can be a database or data warehouse. Let me write here. It can be a database or data warehouse, or even it can be a data lake, right? Data like HDFS, ADLS Gen2, Amazon S3, all these things. Or it can be from a simplified or SFTP location, or it even can be a APIs. So we can pull data from APIs as well. It has many connectors. So we can connect to the API and we can pull the data, etc. And what is transformation? So transformations are the steps. So we need to perform on data. Let's, for example, here. So select is one of the transformation. Filter is a transformation. Aggregate is a transformations. So all these things. Aggregate, joins, etc. Right? And load means it is simply loading data to the some location, saving data. So first it will extract the data and apply some transformations like select, filter, aggregate, joins, and it will load data to some location. So this is ETL operation. So like what is difference between Spark and traditional tools? So we already talked about this. So traditional tool like MapReduce, it is very slow and it is a disk based and it it is difficult to write the MapReduce code for even a simple operations, right? Compared to traditional tools, so Spark has all these features. So Spark is faster because it don't require any disk operation. So it requires only the disk operation at the time of read and at the time of write. So in between, it don't require any disk operation. And also, writing a Spark code is easier and it supports multiple APIs like data frame, data sets. Even you can connect to the Hive databases. So like this, it supports multiple APIs. And also Spark can process both batch and streaming data. So we can use in two applications. Either it is a batch application or streaming application. So we can use the Apache Spark. So this is why Spark is become a core skill for data engineering. Right? So if you go to the interview, so Spark is one of the high weightage uh, tool they will ask in the interview. Right? So because of all these reasons. So even if you are if you wanted to develop any application, ETL application, so the majorly they will prefer Apache Spark only. Right? And also this Apache Spark is open source. Anyone can go to the internet and download the software and install and use it. Right? And also it's it supports multiple languages. So you can write a code in any language. Even if you know the Python, Scala, Java, or SQL, you can write a Spark code, right? Okay, so Python. So in Python, so we can write the PySpark code. So in Scala, so we can write the code in Scala as well, Java as well, SQL as well. So in this series, we will primarily focus on PySpark because it is widely used in the industry and easy to learn it. I hope you are understanding. So in the definition, I mentioned Spark is a general purpose, in memory, plug and play compute engine, right? So now I will talk about all these four keywords which I mentioned here. The first one, so I will talk in a reverse order. So then you will connect the dots. Compute engine. Right? So before talking about the compute engine, what Hadoop provides? Let's first understand Hadoop ecosystem. So what Hadoop provides? So Hadoop provides three things. One is HDFS, the other one is MapReduce, the third one is YAR, yet another negotiator. So we use HDFS for data storage. Data will be stored in the HDFS location. MapReduce is for computation purpose. And YARN is for resource allocator. Right? So in HDFS, we store the data. By using MapReduce, we perform the tasks on top of the data. The computation means the steps we perform on the data. And YARN is used for resource allocation. So resources means, so to execute the particular job, how much memory is required, how many cores required, all these things. How many executors required to process this data. So all the resources is allocated by R, right? So is Spark replacement of Hadoop or is Spark alternative of Hadoop? No. Spark is replacement or alternative of MapReduce. No. Spark is a replacement of MapReduce only. So Hadoop provides three things, but Spark don't provide all these three things. Spark provides only computation capability. So that's why Spark is replacement of MapReduce, not entire Hadoop. Okay. And also, I mentioned Spark is a plug and play compute engine, right? Plug and play. Spark is a plug and play compute engine, which require two things to work with it, right? So if Spark fit into this area, Spark requires two things. One is for data storage, the another one is resource allocator. It requires two things. Two things. One is storage, another one is resource manager. Storage. So I call it as a plug and play, right? So you can plug our Spark with any storage system. So the any storage means it can be a HDFS, it can be a ADLS Gen 2 in Azure, or it can be a AWS in S3 in AWS, or even it can be your local system. So it will work. So or even it can be a Google Cloud Storage from Google. And resource manager. So in resource manager also, we have multiple options. So the resource manager, we can use YAR from Hadoop, or we can use Mesos, or we can use Kubernetes. So that's why the Spark is a plug and play compute engine. So it provides only compute, but for storage and resource manager, we can choose anything. I hope you are understanding. And also I mentioned in memory. In memory. So first, how MapReduce works. So we already talked about this thing, right? Let's, for example, we need to perform these operations. Select, filter, aggregate, and uppercase. Right? So the select means selecting a columns. Simply it is a select in our SQL, and filter, it is simply a where class in our SQL, and aggregate means any aggregate operation. Let's, for example, some operation I wanted to do it. And after this, I wanted to do the uppercase. So this is a string operation. So it will convert the column into uppercase letters. Right? So how MapReduce execute these steps? Right? As I mentioned before, each step in MapReduce requires disk reads and disk writes. Right? Similarly, in a select page, it will read the data from the disk and it will write data back to the disk like this. So it will read the data from the disk and select the columns and write data to the disk. So whatever the data it is selected, that data it will write to the disk. And also we have filter operation next to select. So filter operation also it will work in same way. It reads the data from the disk from select, right? And filter the data, and it will write back to the disk. So it apply the filter. Whatever the data comes after the filter, it will write to the disk. So we have one more operation, sum. Sum, right? Aggregate function. So this also works similar way. So first it will read the data from the disk from filter operation and do the aggregate operations, maybe a sum in this case, and whatever the data comes after this aggregate operation, that data will be written to the disk. And also we have one more operation, uppercase. So after this result, I wanted to convert few columns into uppercase, right? So the same way, it will read the data from the disk from aggregate operation, and it will convert into uppercase and write data to the disk, and so on. So even if you perform 100 steps here, so 100 times it needs to read the data and 100 times it needs to write the data. So this is how MapReduce works. So this is the reason MapReduce is 10 to 100 times slower than the Spark, because it requires more disk writes and more disk reads, more disk writes. So now you understood so how MapReduce works. Now I will show you how Spark works. How Spark works. So we know Spark is an in-memory compute engine. So all the steps will execute inside the memory itself, right? Let's, for example, the same steps you wanted to perform in Spark. So how it will perform is, so first it will read the data from the disk, right? Once read from disk to memory. Once it reads, it do all the steps inside the memory itself. It don't write any data to the any location. So first it will do select operation. This data will go to the filter operation inside the memory itself. So the data will transfer inside the memory itself for all the steps. So once all these your transformations are completed, and if you wish to write the data to some location, so here it requires a disk. So it will save your data. Save data to the maybe HDFS. So how many disk reads required here? Only one disk write, right? And it will load to the memory. Once data is loaded to the memory, and it will perform all the steps. So once all the steps are completed, we will load this data to the disk. So only one disk read and one disk write required. So this is the reason Spark is 10 to 100 times faster than the MapReduce. I hope it is clear. And also, I mentioned general purpose. General purpose. So why it is general purpose? So in your Hadoop ecosystem, so if you want to perform, if you want to clean the data, so we were using pig. So or if you wanted to query some data, So we were using Hive. And if you wanted to ingest the data from some external location, from database or data lake or API, sorry, not API, especially from database, right? Extract or ingest data from database. So we were using Sqoop. Sqoop, Sqoop is one of the ingestion software in Hadoop, right? So, but Spark is capable of handling all these tasks. So data cleaning we can do in the Spark. Even queries also we can do by using Spark SQL, and even we can extract the data or ingest the data from database, data lake, or any other location. So that's why it is a general purpose compute engine. I hope you are connecting the dots. So why I'm saying it is a general purpose in memory compute engine, and uh, why Spark is 10 to 100 times fast because of this disk operations, more disk operations involved in the MapReduce. And also I talked about what is ETL. So what is the ETL process? And also, I talked about what are the languages supported in Spark, and especially, so we will be focusing more on PySpark. So because the PySpark is widely used in the industry. Yeah. So that's it for this session. So we'll we'll talk more about Spark in the upcoming sessions. Thank you.